Okay, now this is example 6 on page 51. And the example is, if W is a non-real cube root of unity, show that the conjugate of W, or W bar, is also a root. Okay, now let's start with what we've got. Remember, with our cube root of unity, we're solving z cubed equals 1. Now, if W is a non-real cube root of unity, then we can say that W cubed is also equal to 1. In other words, it will satisfy that equation. Here's our polynomial, z cubed is 1. So, and if W is a non-real cube root of unity, we know that W would satisfy that equation, z cubed is 1. So we've got that W cubed equals 1. Now, if we know that that applies, we can therefore take conjugates of both sides. So taking conjugates of both sides, we therefore know that here we've got W cubed is 1, which happens to be 1 plus 0i. So taking conjugates of both sides, we know that W bar cubed, or W cubed bar, sorry, is equal to 1 plus 0i, the conjugate of that. Okay, that means, now, there were many rules that we looked at earlier. The conjugate, if I take the conjugate of this power, then it's also equal to the power of the conjugate, okay? So the conjugate of W cubed is equal to the conjugate of W, which is cubed. Now, the conjugate, so that's because the conjugate of a power equals the power of the conjugate. Conjugate. Okay. Now the conjugate of 1 plus 0i is the same as 1 minus 0i, which happens just to be 1. Okay. So, which just happens to be 1. So therefore, we can see that conjugate of W is also a root. Okay, as W bar satisfies the equation z cubed equals 1. Okay. Now from part A, we know, or even just looking at the question, if we've got z cubed equals 1, we know that the three roots, so the three roots of z cubed minus 1 equals 0. Remember, if we're solving z cubed equals 1, that is the same as z cubed minus 1 equals 0. So the three roots of that are 1, because we know that, even looking here, that 1 cubed equals 1. That's the real cube root of unity, and there are two non-real cube roots, and we know that W is one of them, and the other one is W bar, okay, or conjugate of W. So the three roots of z cubed minus 1 are equal to 0 are 1, W, and W bar. Now, we have to show that if the sum of those roots is equal to 0, so you can see sum of roots. We know that sum of roots of a polynomial equals minus b on a. Now, with z cubed minus 1 equals 0, we've got that a is 1, b is 0, and c is also 0, okay? So the sum of the roots, so 1 plus w bar, is equal to negative 0 over 1, which is 0. Now, in part C, we have to show that 1 plus w squared is also equal to 0. Now, we know that we've started off with w cubed equals 1, so therefore w cubed minus 1 equals 0. We know that 1 is a factor, so therefore, what I'm just going to do here is factorize this. We know that w cubed minus 1 is equal to w minus 1. Remember, this is the difference of two cubes, okay? So it's really w cubed minus 1 cubed is w minus 1, w squared plus 1 times w plus 1. Now, if we've got that is equal to 0, Therefore, we can say that w minus 1 equals 0, or w squared plus w plus 1 equals 0. Okay, now this, of course, is factorising using the difference of two cubes. Okay, and therefore we've proven our result there. Okay, now just also going back to the question, sorry for this, because we know that w is non-real, therefore we can just say this result, that 1 plus w squared is equal to 0. So I'll just write there, but w is non-real, so therefore 1 plus w squared is equal to 0. Now the reason we're saying this, if I say that w equals 1, that means that w is real, and we know, so I can't write that w equals 1 here, all right? We've got w is a non-real cube root of unity. I know that one of my roots is z is 1. Okay, so where I've got here that the 3 roots of z cubed minus 1 are those, I'm just going to write that their z equals 1, w, and w bar. Okay, w is the non-real cube root, so I can't say down here that w equals 1. Okay, so that's why I'm saying, but w is non-real, therefore w squared plus w plus 1 equals 0. Okay, so it's really important that you say that. Okay, now with result D. Now to prove this result in D, we'll need to use our results from our earlier parts. Okay, now our results from earlier parts are that w cubed equals 1. So using the fact that w cubed equals 1 and that 1 plus w squared is equal to 0, and doing some rearranging, we know that 1 plus w squared equals negative w, and we know that also, rearranging this, we know that w plus w squared is equal to negative 1. Okay, now the reason we're doing this is we're trying to prove this expression here, that 1 plus w squared cubed times 2 plus 3w plus 3w squared equals 1. And these are the only two results, if you look back here, that we've got. We know that w cubed is 1. Okay, and we know that, just looking at what we've got here, we're not using conjugate of w. The other result we know that we've got is 1 plus w squared is 0. So that's really all that we can start with. Reason I'm rearranging this is so that I can come up with an expression for 1 plus w squared there, so it's negative w. And here we appear to have, look, we've got 3w plus 3w squared, but if we know that 3 plus w squared is negative 1, then this will be just 3 bracket w plus w squared. So we can, you know, we can use this to get this result here. Now we're trying to show that this is equal to 1, so let's start with it. So we've got 1 plus w squared cubed times 2 plus 3w plus 3w squared. Now 1 plus w squared is negative w, and that's cubed, times 2 plus this next bit in a number of ways, but I think probably the easiest way is to go 2 plus 3 bracket w plus w squared. Now, negative w cubed, I'll just write that again. So I've got negative w cubed times 2 plus 3 times, now w plus w squared is negative 1. So I've got negative, now I know that w cubed from up here equals 1. So I've got negative 1 times 2 minus 3, which is negative 1 times negative 1, because 2 minus 3 is negative 1, which happens to be positive 1. Now, another way I could have done that, I could have also gone equals 1 plus w squared, and then I could have written this as 2 lots of 1 plus w squared plus and you'll just see it done like this in your textbook. So we've got 2 plus w plus 2w squared, but we need 3w plus 3w squared, so we need another w plus w squared. Okay, now it's fine because 1 plus w squared we know is negative w. Sorry, that's cubed as well. So negative w cubed. Then we've got 2 lots of this. 1 plus w squared we know is 0. So we've got 2 lots of 0 plus we know w plus w squared is negative 1. So, and then we know that we've got negative w squared times 2 minus 1, which is negative 1. And we know that w cubed is negative 1, so we've got negative 1 times negative 1, which is 1, and hence the result is proven. That's just showing you 2 ways of doing it. So there are, several ways of doing it. That's the end of that question, which is example 6 on page 51. In example 7, if 1w, it's very similar to the question before, okay? If 1w and w squared are the 3 cube roots of unity, state the values of w cubed and 1 plus w squared, and hence simplify each of these expressions, 1 plus 3w plus w squared, and 1 plus w plus 3w squared, and show that their sum is negative 4, and that their product is 16. Now let's start. We know that 1w and w squared are the roots of z cubed equals 1. Okay? Now, since w is a cube root of unity, therefore, and it actually satisfies this equation, therefore we know that w cubed equals 1. So therefore we've stated the value of w cubed, okay? Now, also we know that if 1w and w squared are the roots of, remember we can write z cubed equals 1 as z cubed minus 1 equals 0, then the sum of the roots, which is 1 plus w squared, is minus b on a. Remember, we just did this in the last question, which is minus. Now, here we know that a is 1, b is 0, so which is negative 0 on 1, which happens to be 0. So, therefore, the value of 1 plus w squared is equal to 0. Now, that's part A. Now, for part B. We're trying to simplify these expressions, 1 plus 3w plus w squared. So looking at the first one, 1 plus 3w plus w squared, all squared, is the same as 1 plus, now remember we're just going to try and use combinations of what we've got up here. We know that 1 plus w squared is 0, so it would be the same as 1 plus w plus w squared. So it's the same as 1 plus w squared plus another 2w squared, okay? Reason I'm writing it like that, this is still the same. 1 plus w plus 2w is 3w, and we've got the w squared there. The reason I'm writing it like this is that we know that 1 plus w squared is 0. So that's the same as 0 plus 2w all squared, which is 4w squared, and here we can write since 1 plus w squared is equal to 0. Okay, so we've simplified the expression 1 plus 3w plus w squared all squared, and we've got 4w squared. And let's look at the second expression, 1 plus w plus 3w squared all squared would be the same as 1 plus w squared plus 2w squared all squared is going to be 0 plus 2w squared all squared, which is 4 lots of w to the power of 4. Now, we know that, and again, this was since 1 plus w squared is equal to 0, and so we've got that equals 0 plus 2w squared is 4w to the power of 4. Now we know from earlier in the question that w to the power of 3 is 1. So this is 4 times w to the power of 3 times w, which is, this is again, yeah, we can write that, and which is 4 times 1 times w, since w cubed equals 1. And so therefore a simplified expression for 1 plus w plus 3w squared all squared is 4w. So now simplify each of these and show that their sum is -4 and that their product is 16. So therefore, looking at their sum, so we've got 1 plus 3w, sorry, plus w squared squared plus 1 plus w plus 3w squared squared is the same as, so we're looking at their sum, okay? It's the same as 4w squared plus 4w, which is 4w squared plus w. Now I really can't do much with that, okay, because I really only know what w squared plus w plus 1 is. If we look back up, it's up somewhere. Yeah, we know that 1 plus w squared is 0. So I really do want to try and form that. I need to use this, okay? So if I've got that that's 4 lots of w squared plus w plus 1, so I've got 4w squared plus 4w plus 4, well, I need to take away 4, okay? And so therefore that is 4 times 0 minus 4, which happens to be 0 minus 4, which is -4. So therefore the first result is proved that their sum is -4. Now the product, so looking at the product of 1 plus 3w plus w squared squared times 1 plus w plus 3w squared squared is the same as 4w squared times 4w, which is 16w cubed. Now we know that w cubed equals 1 from earlier in the question. If you look up here, there it is, w cubed is 1. So that's the same as 16 times w cubed, and you might want to write as w cubed equals 1. And also you want to write here, since 1 plus w squared is 0, you really need to refer to where you're getting it from. So it's 16, sorry, times 1, I should put the times 1 there, which is 16, and therefore that result there is also proven. Okay, so that's the end of example 7 on page 52.